بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Some exercises about section 2.2. Find the vertex of the graph of the equation. Well, this is a quadratic function. A is 1, b is -2, the coefficient of x is b, the coefficient of x squared is a, and uh, to find the vertex, we use the formula h is -b over 2a. So it's -2, it would be 2. 2 times 1 is 2, so h is 1. Then we find k. K is y of 1 or f of 1. So I replace x by 1, so 1 minus 2 times 1 is -1. So the vertex is 1 and -1. B, determine whether the vertex is a maximum or a minimum. Well, A is 1, so A is positive. So the parabola opens upwards and the vertex is minimum point, is the minimum point. C, determine what values of x gives the optimal value of the function. Well, x equals h, which is 1, will give the optimal value of the function. D, determine the optimal maximum or minimum value of the function. Well, the maximum value is k, which is -1. But here it's not the maximum, it is the minimum. So the minimum value is -1. That's the answer. Same question, but with a different quadratic function. So I'll start by arranging it. X squared first, then x, then the number. Well, a here is -2, coefficient of x squared. B, coefficient of x is -4, and C is 6. Part A, find the vertex. So h is -b, it is 4 over 2 times a. 2 times -2 is -4, so h is -1. Then k would be y of -1. I replace x by -1. So it's -2 times -1 square, which is 1, minus 4 times -1 is +4, and I have +6. So 10 minus 2 is 8. So the vertex has coordinates -1 and 8. B, determine whether the vertex is a maximum or minimum. Well, this depends on A. A is -2, it's less than 0. So the parabola opens downwards. And if the parabola opens downwards, the vertex would be the maximum point. C, determine what value of x gives the optimal value. It is h, which is -1. D, what is the optimal value, which is the maximum? The optimal value is 8. Okay, the maximum value is 8. The maximum point is -1 and 8. Determine whether each function's vertex is a maximum point or a minimum point, and find the coordinates of this point. Well, let me write it. -1 over 4x squared first, and then plus x. So a is -1 over 4, and that's less than 0, and b is 1. Less than 0, so the parabola will open downward. And if the parabola opens downward, then the vertex is the maximum point. All right. Find the coordinates of this point. To find the coordinates of the vertex, we find h, which is negative b over 2a. So it's negative 1 over 2 times negative 1 over 4. 2 times negative 1 over 4 is negative half. So negative over negative is positive, and this is 1 over half, or 1 times 2, or 2. So h is 2. Now k would be y of 2. So I replace x by 2. So negative 1 over 4 times 4, 2 squared is 4, is negative 1, plus x is 2, so k is 1. So the vertex has coordinates h2 and k is 1. So we found the coordinates of the vertex. Find the zeros, if any exists. Well, the zeros, to find the zeros, we put y0. So we have negative 1 over 4x squared plus x equals 0. I can multiply by negative 4. So I will have x squared minus 4x equals 0 times negative 4 is 0. And now I can take x as a common factor, and I can find out that the zeros are either x equals to 0 or x equals to 4. So these are the zeros or x intercepts of the function. Find the y-intercept. Well, the y-intercept, we put x0, and if you put x0, you get y0. So the y-intercept is 0. Then sketch the graph of this function. Well, let us sketch the graph of this function. The coordinates of the vertex, 2 and 1. 2 and 1. It opens where? Downwards. What are the x-intercepts? 0 and 4. So this is the graph of this parabola. This is the vertex. These are the x-intercepts. This is the y-intercept. Even if he asks about the coefficient, the equation of the axis of symmetry, it is x equals 2. Okay. Uh, this is not written in the form, so I will write it. So I will take y to the other side. So I will have y equals, if I take y to the other side and bring 3 here, I'll have half x squared plus x minus 3. All right. So just taking y here and 3 here, and write y first, or change. So write y here in the right hand side, in the left instead of the right hand side. So half x squared plus x minus 3. That's the equation. So what is a? It is 1 over 2. What is b? It is 1. What do we need to find? Determine whether each function's vertex is maximum point or minimum point. Where a is positive, so the graph opens upwards. So vertex is what? The minimum or the maximum? The minimum point. Then find the coordinates of this vertex, okay, of this point. Well, h would be negative b over 2 times half, which is 1. So it's negative 1. What about k? K is y of negative 1. So it is half times negative 1 square, which is 1, plus x, so minus 1, minus 3. So minus 4 plus half, this is minus 3.5 or 7 over 2. All right, minus 4 plus half minus 3.5. All right, so the vertex is -1 and -7 over 2. What else? Find the zeros. Okay, let us find the zeros of this function. We put y0. So half x squared plus x minus 3 equals to 0. I will multiply by half. So x squared plus by 2, sorry, I need to multiply by 2. So 2x minus 6 equals 0. When I multiply 2 times half, I get 1. 2 times 1, 2. 2 times -3, -6. Now try to factor. Do we have two numbers with uh, with product -6 and uh, sum 2? 2 times 3 is 6? No. So I will use the quadratic formula to solve this equation. So A is 1, B is 2, C is -6. So X would be negative B, -2, plus or minus square root of B square, which is 4, minus 4 times 1 times -6 over 2 times 1, which is 2. So I have -2 plus or minus square root of, this is 4 plus 24. So it's 28 over 2. And then it would be -2 over 2 plus or minus. 28 is 4 times 7. So I can take 4 out to be 2, and I'll have 7 here over 2. So I will have -1 plus or minus square root of 7. I need to approximate them. So -1 plus square root of 7 is approximately 1 point. So the zeros are 1.65 approximately and -3.65. So these are the zeros. Find the y-intercept and then sketch the graph. Well, the y-intercept, when we put x 0, we get -3. So the y-intercept is -3. Let us sketch the graph. The vertex -1, -7 over 2, and it opens up. That's good. So -1, -3.5. So this one. So this is the vertex, and it opens up. The y-intercept is -3, so it will go like this. And since this is -1, and this is 1 point, and this is 3, so if we go 1 point to the left, also we will have -3. So it will open like this. Okay, so no need for these two. Okay, so because this is the axis of symmetry, if I have the coordinates of this point 0 and -3, then I have another one which is -2 and -3. Now, where are the x-intercepts? Either I have what or the zeros 1.65. So this is 1, this is 2, this is the x-intercept, and -3. So this is -2, -3, this is negative the other x-intercept. So it will go like this and like this, and this is the graph of this parabola. Y-intercept is there, x-intercepts zeros are there, everything is fine, and the vertex is minimum. Tell how the graph of y equals x squared is shifted. Well, 3 units right and 1 unit up. So what would be the vertex, the new vertex? When we take it 3 units to the right, it would be 3, 1 unit up, 3 and 1. Graph the function. Remember, A is positive, all right, so it will open upwards, like similar to x squared exactly. Only the vertex has changed to 3 and 1. So 1, 2, 3, so exactly equal to x squared. So I just graph it like this. If you want to find the y-intercept, you can, okay? If x is 0, the y-intercept would be 9 plus 1, 10. So it's very up there. So I'll just, uh, uh, this would be okay. This graph is just fine. Okay, here. Well, 2 units were left and 2 units down. So what would be the new vertex? 2 units left, it would be negative 2. 2 units down, it would be also negative 2 when you take it 2 units down. So what would be the graph of this function, of this parabola? Well, negative 2 and negative 2. So you took the graph x squared, 2 units left, 2 units down, and then you graph the parabola. If you want, you can find the x-intercepts, okay? To find the x-intercepts, it would be fine if you don't find them, but if you want to find them, you put y 0, okay? If you put y 0, I'll have x plus 2 to the power 2 minus 2 equals 0 or equals 2. Then x plus 2 using the zero factor property would be plus or minus square root of 2, and then x would be negative 2 plus or minus square root of 2. And you can approximate these two numbers, negative 2 minus square root of 2. This is about negative 3.4. So this is negative 3. It's about here. So the graph will go from here. And if you find positive square root of 2, it is negative zero point 0.6. Negative zero point 0.6. So this is 1. This is negative zero point 0.6. So the graph will go from here up. So this is the graph of this parabola. If you just take it up, it's okay here because we are just, he did not ask about x-intercepts or y-intercepts. The last point in this section would be the average rate of change. Well, here the quadratic function, it's not a line, so the rate of change or the slope is not constant, okay? But we can define the average rate of change of the function between two input values. How? Like this. It is how much the output values change between the two input values. So if we have x equals a and x equals b, the average rate of change of f of x with respect to x from a to b would be f of b minus f of a over b minus a. So change of f of x over the change in x. So it is the slope actually. The slope between, you can say the slope of the segment or the secant line between these 2 points, AFA and BFB. So FB minus F of A or the change in Y over the change in X, that's the average rate of change. Example, find the average rate of change of this function between these two values. So to find the average rate of change, I need to find f of 1. What is f of 1 or y of 1? Negative 5 minus 1. This is negative 6 minus 5 times 1 minus 1, negative 6. And what is f of negative 1? F of negative 1 would be negative 5 times negative 1. This is 5 minus negative 1 square is just 1. So it is 4. Again, negative 5 times negative 1, 5 minus 1, that's 4. So what is the average rate of change? It is f of 1 minus f of negative 1. over 1 minus 1. F of 1 is negative 6. F of negative 1 is 4. 1 plus 1 is 2. So negative 10 over 2 is negative 5, and that's the average rate of change of the function. Here also, average rate of change. We find f of 4 or y of 4. It would be, let us find it by the calculator, 8 plus 3 times 4 plus zero point 0.5 times 4 square or 16. Then the answer is 28. F of 2. Well, it is 8 plus 3 times 2, that's 6, plus zero point 0.5 times 2 square or 4. So the answer is 16. So the average rate of change would be f of 4 minus f of 2 over 4 minus 2. So f of 4, 28, f of 2, 16, 4 minus 2 is 2, 28 minus 16 is just 12. So 12 over 2 is 6. So this is the average rate of change of the function from 2 to 4. The monthly profit from the sale of X units of a product is given by this quadratic function. What level of production maximize profit? Well, notice that the coefficient of x squared is negative. So parabola opens downwards. And the vertex would have coordinates h and k. So what level of production? X or h, okay? Which is x, which is negative b over 2a. So what is a here? A is negative 0.01. It's the coefficient of x squared, and b is the coefficient of x. Okay, it's not arranged. If you want to arrange the equation first before finding the vertex, then it's okay. Or if you know that a is the coefficient of x squared and b is the coefficient of x. So negative 16 over 2 times negative 0.01. And let us just use the calculator. So negative 16 over 2 times negative 0.01, and the answer is 800. So this is the level of production that maximize the profit. What is the maximum profit? Well, to find the maximum profit, it is P of 800. So we replace X by 800. So it would be negative 0.01 times 800 square plus 16 times 800. So replacing x by 800 minus 900. And we can use the calculator to find this maximum profit. So plus 16 times 800 minus 900. The answer is 5,500. So this is the maximum possible profit is $5,500. This was the last question. I hope this section is easy. Please study hard.